Hello, welcome back. And today we will be doing our lab on our EVAP system for leak detection and purge control. We did three vehicles for our lab today. First vehicle we have is a 2011 Hyundai Sonata 2.0 turbo. Second vehicle will be a Cadillac ATS 2.0 turbo all-wheel drive. And the last car will be a 2012 Chrysler 300 SRT8. On our visual inspection of the 2011 Hyundai Sonata, we depicted that there was no damage to the purge control valve in the engine bay. We were also able to lift the car and able to check the charcoal canister, the vent valve, and the air fuel filter that is underneath the vehicle as well. And it seems like they were all working in great condition. Gas cap seal is in very good condition. The gas cap was replaced within the last year. I know this due to this being my personal vehicle, and I do not have a specific testing port for my vehicle. For codes P0456, the PCM measures pressure differential curve in the fuel tank, and it sets P0422 or P0456 is vacuum generated within monitored period, increases over a defined threshold, especially in the same era of the next drive cycle. The PCM illuminates the mill. And for P0455, the vacuum phase generation will determine if there is a large leak like a tank cap open or canister shutoff valve stuck open. PCM sets P0455 if pressure in the tank does not drop as low as predetermined threshold during maximum vacuum generational period. And then for slow fill concern, because my vehicle actually has this problem, P0449 will set on the vehicle, which is a complaint of difficult fuel tank filling to accompany the EVAP vent circuit codes. It is considered a very common cause, and when we do further inspection, we see that the canister that's underneath the vehicle is actually leaking out smoke when we commit our smoke test, and it shows that it is not holding any of the EVAP contents, especially like the gases that are from a refilling event, and it is deemed that the canister is unsatisfactory and needs to be replaced. And for our second part of our lab, we were sent out to go find the fuel tank pressure voltage change, heated O2 sensor voltage change, short-term fuel term change, and purge solenoid command. For purge solenoid command percentage, we got at about 8%. Fuel tank pressure fluctuated between about 1.3 volts to about 1.7 volts or so. Heated O2 sensor was between 0.17 volts and about upwards of 0.8 volts, and short-term fuel trim stayed between 4% and -4%.
Another thing that we noticed on our 2013 Cadillac ATS is that when we manipulated the command percentage for our purge solenoid, the car had a different operating noise, and you would hear how it would adjust every time you press the button.
Yes, and as well as engine operation, you will also see on our scan tool that we'll show in our video, the PIDs jump up as well as the voltages and as well as the command percentages and short-term fuel term. They all change, and we can see that in audio and in visual recordings.
Okay, so now we're moving on to our simulation test on our 2012 Chrysler 300 SRT8. So first we created a small leak with the EVAP monitor, and basically when we did that, we heard a difference in the engine operation. Like, we heard a different sound, and we heard like the gases passing through the CCV. So this test took roughly 30 seconds to complete, and basically when we observed the PCM detection time and readiness monitor, it took oh my gosh, restart.
over our inspection of the gas cap and of the purge valve up front in the engine bay as well as underneath the vehicle, we see that all the seals seem to be intact. Everything seems to be functioning as it should properly, and there don't seem to be any visible signs of brakes, corrosion, or... Hello, and today we'll be looking at my personal car, a 2011 Hyundai Sonata. Car currently has a P0449 code, which is a vent solenoid malfunction. And today we'll be testing our system with the smoke machine we have here. And underneath the car, we'll be testing at the fuel tank air component right there, and right here is the charcoal canister. Now testing for a leak, I should say, on the 2011 Hyundai Sonata. When we first started initially, that black dot was initially up here and then gradually started decreasing over time as the fuel tank and the evaporator system starts to fill with the air that's going into that line. As you can see with the connector right there, it's a little hard to see. Alright, that should be. Alright. Luckily, we already have a removed fuel tank air filter, which is right here. And we're testing the smoke. As you guys can see, we now have the smoke hooked up to the canister back here, and through the top of that canister right there, you see the smoke is pouring out the top through a little crack up there. It's probably broken, probably needs to be replaced. This is connected to the charcoal canister right here, as you can see. And it looks like our probable cause might be to replace this canister. As you can see, it's just constantly just coming out. And it's not supposed to do that. It's usually supposed to go through all of here, and it usually vents out on this side into the canister. Hello, and welcome back to our video. Today, we are now diagnosing a Cadillac ATS 2013 2.0 turbo, and we're now looking at the heated oxygen sensor value, the evap per solenoid valve command percentage, fuel tank pressure in volts, and short-term fuel trim in percentage here. As you can see, we get a very even displacement for our short fuel trim, which is about -3, -4 at idle, and it goes positive and it goes back negative. As you can see, it fluctuates. Heated O2 stays from about 0.8 volts and jumps around to about 0.8182 volts. Evap purge valve command stays about the same, about 8%. And fuel tank pressure stays steady about 1.4, 1.5, and flushes about 1.67 or 7 in general. Alright, after some searching, we finally were able to get our command for our evap emission for purge solenoid control. Our current command state is actually at 8. It's at what was actually 8 to 10% right now, and each time we hit the increase button down here, it will increase the command state by 10%, and we will start to see what that does to our changing pits. Go ahead. And if we go up to about 40, 50, short-term fuel trim fluctuates. It gets to about -6 compared to -4. And if we increase that to 70 and 80%, we see short-term fuel trim reaches a positive number of about at the highest about 10%, 12%, 13 and climbing. And once we get to about 100 of commanded purge, as you can see, the fuel tank pressure drops substantially. Fuel tank pressure sensor stays about the same. Heated oxygen sensor stays about 0.2, 0.3 volts. And short-term fuel trim goes up to about 30% and is continuously climbing.
Another thing that's worth noting is when we increase, and when it goes into effect, you can hear how the engine temporarily runs in a different manner. And and then it turns back to normal. I don't know if you heard that right there, but it kind of sounded like it had a higher pitch and dropped down back to where it was normally at.
We are now doing our purge simulation test on our 2012 Chrysler 300 SRT8, and we will now be starting it with the purge vapor system open. Continue. This is about a 30-second test. See, engine operation, engine speed drops when we command it open. As well as you see the drops, it starts to burn, picks back up. And you can also audibly hear the engine start to operate a little bit differently. We have now created our small leak here right at the canister inside the engine bay. We will now be testing the Verge vapor system whenever it open. If it and so you can audibly hear the air coming through that hose, as well as the engine operation changes slightly. Engine speed is about 600. Stays this parameter. You see short-term adaptation goes from about -4.3 and fluctuates to about 1.6, and short-term adaptation for the closer up front HO2 sensor is about -3.5 to about -2.2.
Okay, so now we're moving on to the 2012 Chrysler 300 SRT8. So when we created a small leak at the CCV, the EVAP monitor didn't immediately detect it because many vehicles only run the small leak test after the large leak test passes. And during our bidirectional test, we could hear engine changes and vapor flow, and the test itself only lasts about 30 seconds. The purge monitor has 2 stages and won't run until the system passes the small leak test. And because the small leak monitor never ran, no EVAP codes were set in this test.
And we will now be talking about our components of our EVAP system on our vehicle. For number one, the PCV recycles blow-by gases back into the engine. The canister stores fuel vapors, and the purge solenoid transfers those vapors into the intake manifold where they are burned again. The tank pressure sensor checks for EVAP leaks. The canister closed valve seals or opens the system. The tank air filter cleans incoming air. The fuel level sensor, the fuel level sender sensor reports how much fuel is in the tank, and the catalytic converter converts hydrocarbons and other emission gases in the exhaust before it leaves the vehicle to be safely dispersed into the atmosphere.
Now we'll be presenting the DTCs for our 2011 Hyundai Sonata.
Alrighty, we will now be moving on to the conclusion. And for my conclusion, I would say that this lab taught us how to diagnose key EVAP components and understand how the EVAP system stores and burns fuel vapors, using the 3 different manufacturers to help us understand and acknowledge the different EVAP designs and how they work in those particular vehicles, especially with their procedures. We felt that the lab overall was a good, useful, hands-on way to apply lecture concepts and to learn to test parts in real-world situations to diagnose and fix problems such as evaporative problems that can cause emissions, unrelated concerns to the vehicle.
So what I took away from this lab is learning how to do several tests, and I thought it was really cool that we got to do the EVAP thing on his car. Like, he actually had an EVAP issue, and we got to apply our knowledge that we picked up in class and use it out there in the lab. The smoke test was one of the most interesting tests to me because we actually got to see the part failing the test. I didn't expect it to fail the test because, again, we didn't know what was wrong with his system.
Exactly,
and I
yeah.
didn't expect it to fail at that point. But we got to see what, like, a component failing a smoke test was like. And then when we were on the Chrysler and the ATS, the Cadillac ATS, both times I was hearing, when we were doing our test, I was hearing a difference in engine operation or airflow in the system. So on the ATS, I mentioned this earlier, obviously, but it helped me kind of understand the lab more when we were changing the command on the purge solenoid, and we were hearing the difference in engine operation every time we were hitting the button. And then on the Chrysler, when we were doing the test, when I had unhooked the line, you were able to hear air coming out of the line. And I didn't know what to expect because I had never done that before, but it was a really cool experience, and I think I'm gonna build off this experience going forward. So
Yeah. And I would also like to conclude with more on my vehicle. So I have a P0449 code, and I get a slow fuel concern. It's usually based upon if the vent solenoid that is for the fuel tank. When I am in the refueling process, it does not vent them into the canister correctly, and actually it was actually leaking out the top of the canister, as you guys will see when I will implement that part, that part of the video on our actual lab. And for the most part, I would just say it's more of like a wake-up call for me to be more productive about, like my emission problems on my vehicle. And it definitely has been an eye-opener when it comes down to diagnosing and servicing these type of vehicles. But overall, I do feel like the lab was a success and that we learned greatly from it.
thank you for watching.
Yep, thank you guys for watching. Hope to see you guys next time.